Hello students, in today's video we're going to work on antiderivatives and slope fields. So let's get started. Go ahead and try working out these three problems and checking your answers in just a second. Hopefully you've paused your screen and you're just coming back to check your answers now. Just to go over it again, this should be x squared minus 3x plus c. Keep in mind, since we did not give you an integral or a definite integral to take the antiderivative of, you have to add that plus c. For number 2, this should become 1/2 sine of 2x plus c. Number 3 should be 1/3 of ln 3x minus 7 plus c. So if you have any questions on this, make sure you remind me in class. Now, we're doing antiderivatives and slope fields. Keep in mind that a function f of x is an antiderivative of f if the derivative of big f of x is equal to f of x. So remember, differentiation and antidifferentiation go both ways. Forward to go differentiation or antidifferentiation to go back to the original. So we talked about definite integrals. If we have a lower and upper limit on our integrand right here, this is going to tell us when it's a definite integral. When it's indefinite, that means there are no upper and lower limit. And in those instances, we always have to add the plus c. So I want you to go ahead and integrate or evaluate this integral. So this should give you an answer of -3 cosine of x plus 1/3. That's weird. Sorry, that's -3 cosine of x plus 1/3 cosine of 3x plus c. Keep in mind I'm doing the plus c. Also, that 1/3 came because if you were to take the derivative of cosine 3x, this would be the sine of 3x times 3. And because it's not in the original, we have to account for that by multiplying by the inverse, which is 1/3. So let's try another problem. So try doing this one again. This should be a quick one. These should all be review, but the answer to this should be, I'll do it slowly and we'll do it in 2 steps. This should give you -x to the -2nd power divided by -2 plus 1/2 x squared minus x plus c. This turns out to be x to the -2nd power plus 1/2 x squared minus x plus c. So let's look at a couple more practice problems. Here's where you're going to see a slight variation here. The last one should look a little difficult, but the first 2 should be pretty basic. This is going to turn out to be 1/2 x to the 4th power minus sine of x plus c. If you're not sure where that 1/2 came from in the front, remember as we added 1 to the 3, really what we had here is 2x to the 4th divided by 4, but I went ahead and simplified that already. For part B, it should be 1/5 e to the 5x plus ln of x plus c. And part C is the one we're going to have to spend a little bit more time on. So here's a quick note. Sine of squared x is equal to 1 minus cosine of 2x, all divided by 2. Okay, so, sorry, for some reason our marker's not working. There it is. So this is what we have. So what we're going to do is we're going to simplify, or rather substitute that into this equation and separate the divided by 2. So really what we have here is 1/2 minus cosine of 2x divided by 2. Now, as we find the integral for each one, this should be pretty basic. We know that this becomes 1/2 x minus sine of 2x divided by 2 because we were missing it, and there was also the original 1/2 there, so divided by 2 plus c. So just to go and explain that a little bit further, this divided by 2 is this divided by 2. These two are the equivalents. What happened here is that because we took the antiderivative of cosine 2x and there wasn't an existing c, or wasn't existing 2 in there, we had to throw one in. So if it makes it easier for you to see, we're going to let u be equal to cosine of 2x, and then du should have been, u is going to be equal to 2x, du is going to be equal to 2 dx. And because this 2 right here wasn't in the original equation, we had to throw that in by dividing this portion by 2, so it should have read dx equals du divided by 2, which is where this divided by 2 came from. So moving forward, this should be gone. And if we take a look at this one again and simplify it further, this is going to be 1/2 x minus sine of 2x divided by 4 plus c. So this is your final answer here. So let's look at differential equations now. Now, a differential equation is an equation containing a derivative. It's called a differential equation. The order of the differential equation is the order of the highest derivative in the equation. The value of f at one x value of x is the initial condition of the problem. Notice initial means one value, or first, or starting. And then solving a differential equation with a given initial condition is an initial value problem. So here are a few examples of what differential equations look like. Notice they all have that dy dx. And then the next thing we want to talk about is a slope field. So a slope field, aka a directional field, for dy dx is equal to f of xy. Now, it sounds complicated, but a slope field is a plot of short line segments with slopes f of xy for a lattice of points in the plane. So write it down, make sure you have it, and then we will talk about that in a little bit. So let's take a look at another quick warm-up problem. I want you to evaluate both integrals to simplify the following equation. So this is an example here of a differential equation. Notice you have your dy on one side, your dx on the other. So before we do that, actually, let me skip one slide ahead. In order for us to solve first order differential equations, we separate the variables, integrate both sides, include plus c on one side, and then use the initial value if given to solve for c. So that's exactly what we're doing here. Now, I do need to make sure we note that cosine squared of y is equal to 1 plus cosine 2y all divided by 2. Notice this was very similar to what sine squared y is, except this one has a plus. So to simplify, we have cosine squared y equals 1/2 plus cosine of 2y divided by 2. Now, to integrate the left-hand side, we're going to do the same thing we did here. We're going to let cosine squared y be equal to 1/2 plus cosine of 2y divided by 2. The left side becomes 1/2 x plus plus 1/4 sine of 2x plus c. So notice I added the plus c on the left side, and that's going to be equal to e to the 3x. When we find the antiderivative of that, it's going to be 1/3 e to the 3x minus 1/3 x to the 6th power. notice here that we have x to the 6th power. We're not going to add a plus c because we already did it on the left. So this should be your final answer. So here is the directions on how to find your slope field. Make sure you have this down, but we will talk about it in class. So getting into solving first order differential equations again, here's what we have. So what we're going to do here is we are going to multiply dx to both sides. What we're going to be left with here is x to the negative 2/3 times dx. Then we're going to integrate both sides. So the antiderivative of dy is y equals, if we add 1 to that negative 2/3, as in x to the negative 2/3 plus 1 dx divided by negative 2/3 plus 1, we're going to be left with y equals x, y equals 3x to the 1/3. Notice we got the 3 here. Because what's going to happen here is negative 2/3 plus 1 is 1/3. And because it's on the denominator, we copy dot flip or invert and multiply, and we get 3 times x to the 1/3 plus c. Because remember, we didn't have a definite integral. Now, when we have an initial value problem, they're saying take your y value, which in this case is negative 5. Notice on the left side here, or right side here, this is going to be your x value. This is what your y is equal to. So, going into that problem, we're going negative 5 equals 3 to the negative 1st power, or 3 times negative 1 to the 1/3 power, plus c. Notice that 1/3 power is the same thing as the cubed root. So negative 1 times negative 1 times negative 1 would be able to break free of that 1/3 power, and you're left with negative 5 equals 3 times negative 1 plus c. You then have negative 5 equals negative 3 plus c, and therefore c is equal to negative 2. Finally, your final answer should read 3x to the 1/3 power minus 2. And that's your final value for the initial value problem. So let's look at another problem, or example. So here we have another type of problem. We're going to separate them again. So notice we have dy equals 1 divided by x squared plus x. Notice what I'm doing here, just to make sure we're clear. Because there's an extra plus x in here, or because there's extra plus anything, we have to make sure we put those in parentheses with the dx. Now when we take the antiderivative, we're going to have y equals negative 1 divided by x plus 1/2 x squared plus c. Remember, we know what the y is. Y is 1 equals negative 1 divided by 2 plus 1/2 times 2 squared plus c. We get 1 equals negative 1/2 plus 2 plus c. And what's going to happen here is we have 1 equals negative 3/2 plus c, and we add that to both sides. That's 1 plus 3/2 equals c, and that turns out to be 5/2 equals c. And finally we have y equals negative 1 divided by x plus 1/2 x squared plus 5/2, and that's your final answer. So this time we're going to do a slightly more tricky problem because this has sine, cosine, and it's a second order differential equation. The reason why you know it's a second order is because now that d is d squared and that theta is squared. So first things first, we are going to set it up. So we have d 2y equals sine of theta. We'll use x in this particular case because it's faster. Cosine x d x squared. Notice how we had to put it in parentheses, and we had to make sure we had that dx squared. We find the first antiderivative of that, instead of it being d2y, it's now going to be dy, because when we go backwards, it's now the first derivative instead of the second, equals antiderivative of sine of x is negative cosine of x plus sine of x. Notice we're putting them in parentheses, plus dx plus c. Always have to add that plus c. Now, it does tell us right here that we know the first derivative, 0. When the first derivative has an x value of 0, the y value is negative 1. So what we're going to do here now is substitute those values in. We know that when we substitute 0 in here, we get negative 1. I know the arrow's covering it, but I promise it's there. Negative cosine of 0 plus sine of 0 plus c. We're going to leave the dx all the way at the end because it doesn't concern us at this point. Next thing we have is negative 1 equals cosine of 0 is 1, so that's actually negative 1, plus sine of 0 is just 0, plus c. C turns out to be equal to 0. So we know that dy equals negative cosine of x plus sine of x dx. Notice I'm making that concerted effort to make sure it's all in parentheses. And now we're going to find another antiderivative. So the antiderivative of y is y equals negative sine of x minus cosine of x plus c. Now we know what the x and y value are here because we have this 0 and we have this negative 3. So we now have negative 3. I'll move this over so you can see it. Equals negative sine of 0 minus cosine of 0 plus c. We have negative 3 equals sine of 0 is just 0 minus cosine of 0 is just 1 plus c. We know that c is now equal to negative 2. And then we substitute that into our original. So final answer is y equals negative sine of x negative sine of x minus cosine of x minus 2 is your final answer. So hopefully that helps. If you have questions, be sure to ask. But that's all for now. I'll see you guys next time.